Something unprecedented just happened in the space between worlds, and the astronomical community is scrambling to understand what they witnessed. On October 3rd, 2025, as 3I/ATLAS swept past Mars at a distance of 30 million kilometers, this interstellar visitor did something that has never been recorded in the history of human space observation. It created electromagnetic disturbances powerful enough to disrupt multiple spacecraft simultaneously while appearing to alter its own trajectory in ways that contradict fundamental physics. The alerts began filtering into mission control centers across 3 continents at 1423 UTC. First came the automated warnings from the European Space Agency's Mars Express orbiter electromagnetic interference patterns. Unlike anything in the spacecraft's 22 years of operation, within minutes, NASA's Mars Reconnaissance Orbiter registered similar anomalies. Then the Trace Gas Orbiter, then MAVEN. 4 separate spacecraft, operating different instrument packages, built by different nations, all detecting the same impossible phenomenon, a comet that was behaving like something far more complex than frozen gas and dust. Dr. Sarah Chen, Principal Investigator for the Mars Electromagnetic Environment Monitoring Program, received the first preliminary data packet at her office in Pasadena at 3:47 a.m. local time. What she saw in those initial readouts challenged everything she understood about interstellar objects. The magnetic field fluctuations were off the charts. She would later tell colleagues in an emergency conference call, "We've monitored thousands of solar system comets passing near Mars. None of them produce electromagnetic signatures, even remotely similar to what we recorded from 3I/ATLAS. The numbers told a story that seemed to violate known physics." As 3I/ATLAS approached its closest point to Mars, instruments detected magnetic field strength variations exceeding background levels by factors of 50 to 100. These weren't gradual changes, typical of cometary interaction with planetary magnetospheres. These were rapid, structured fluctuations occurring in patterns that appeared mathematically organized rather than random, but the electromagnetic anomalies represented only the beginning of the mystery. Orbital tracking stations monitoring 3I/ATLAS's trajectory detected something even more disturbing. The object appeared to deviate from its predicted path during the Mars encounter. Not by much, MINE's initial calculations suggested deviations measured in kilometers rather than thousands of kilometers. Yet, for an object supposedly composed of loose ice and rock traveling at interstellar velocities, even minor trajectory changes required forces that shouldn't exist. The deviation analysis completed by NASA's Jet Propulsion Laboratory using data from the Deep Space Network showed 3I/ATLAS accelerating slightly toward Mars during closest approach, then resuming its predicted trajectory after moving past the planet. This acceleration couldn't be explained by Mars's gravitational field, which had been precisely calculated months in advance. Something else was influencing the comet's motion, something internal to 3I/ATLAS itself. Within hours of the initial alerts, space agencies worldwide activated emergency observation protocols typically reserved for potential asteroid impacts or spacecraft malfunctions. The European Space Operations Center in Darmstadt, Germany, began coordinating data-sharing agreements between normally competitive national programs. NASA's Planetary Defense Coordination Office, despite 3I/ATLAS posing no collision threat to Earth, found itself managing the most significant interstellar object investigation in human history. The timing couldn't have been more crucial. 3I/ATLAS was approaching the period of superior conjunction when solar glare would make Earth-based observation impossible. The Mars encounter represented humanity's last clear view of this interstellar visitor before it disappeared into the sun's overwhelming brightness for nearly 2 months. Whatever had happened near Mars might be the only direct evidence of 3I/ATLAS's true nature that astronomers would obtain during its entire solar system passage. Dr. Roberto Fernandez, mission operations manager for the Trace Gas Orbiter, described the situation in terms that captured the scientific community's growing concern. "We're dealing with an object that appears to respond to planetary proximity in ways we've never observed. The electromagnetic effects suggest internal activity far beyond anything we'd expect from a passive collection of ice and dust. We need to understand what we're looking at before it vanishes into conjunction." The phenomenon raised fundamental questions about the nature of interstellar objects and their behavior in stellar environments. Traditional comet physics assumes these objects remain relatively inactive until solar heating begins sublimating surface ices. Yet 3I/ATLAS was demonstrating complex electromagnetic activity triggered by proximity to Mars, not the Sun. This suggested internal systems or processes operating according to principles not accounted for in conventional cometary models. Emergency data processing efforts revealed additional anomalies in the electromagnetic signatures. The field fluctuations weren't random or chaotic, as would be expected from natural plasma interactions. Instead, they displayed mathematical patterns, structured sequences that repeated with statistical regularity, suggesting underlying organization. Some researchers began using the term structured emissions in their preliminary reports, carefully avoiding more speculative language while acknowledging that the patterns appeared non-random. The international space community found itself confronting the possibility that 3I/ATLAS represented something fundamentally different from previously studied interstellar objects. Unlike 1I/Oumuamua, which displayed mysterious acceleration but remained electromagnetically quiet, or 2I/Borisov, which behaved like a conventional comet despite its exotic chemistry, 3I/ATLAS was actively interacting with its environment in ways that challenged basic assumptions about interstellar visitor behavior. As news of the anomalous readings spread through scientific networks, observatories worldwide began adjusting their schedules to maximize remaining observation opportunities. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and the Hubble Space Telescope all received priority observation requests for 3I/ATLAS monitoring. Time was running out for understanding what had happened near Mars before superior conjunction ended direct observation possibilities. The Mars encounter had transformed 3I/ATLAS from an interesting astronomical curiosity into an urgent scientific priority requiring immediate, coordinated international response. Whatever this interstellar visitor truly represented, its behavior near Mars suggested capabilities or characteristics unlike anything in human experience with objects from other star systems, and the clock was ticking toward the moment when Earth would lose sight of this cosmic mystery for the most critical phase of its solar system journey. The precision of orbital mechanics demanded that 3I/ATLAS's closest approach to Mars occur at exactly 14 hours, 7 minutes and 33 seconds UTC on October 3rd, 2025. Months of calculation had established this moment with mathematical certainty, placing the interstellar visitor at 29.847 million kilometers from the Martian surface, close enough for detailed spacecraft observation, distant enough to pose no collision risk. What nobody anticipated was how dramatically this precise celestial choreography would reveal the alien nature of our cosmic visitor. At 13:45 UTC, 18 minutes before closest approach, the first anomalous readings appeared in the data streams from Mars Express. The spacecraft's magnetometer, designed to study Mars's weak magnetic field and its interaction with solar wind, began registering fluctuations that defied every calibration standard in its operational database. These weren't the gentle variations typical of solar wind pressure changes or seasonal atmospheric effects. These were sharp, structured pulses occurring at regular intervals of 7.3 seconds, a periodicity that appeared entirely artificial in its precision. Dr. Liu Wei, monitoring the real-time data feed from the European Space Operations Center. Mars Express had been operating since 2003, far exceeding its planned mission duration, and aging equipment occasionally produced spurious readings. but the backup magnetometer confirmed identical measurements, and more disturbing, the anomalous signals were strengthening as 3I/ATLAS approached its closest point to Mars. At 13:52 UTC, 15 minutes before closest approach, NASA's Mars Reconnaissance Orbiter joined the electromagnetic chorus. Its instruments, originally designed for mapping Martian mineral deposits and atmospheric composition, detected radio frequency emissions in bands that should have been empty space. The signals exhibited characteristics unlike any natural astronomical phenomenon in the spacecraft's operational experience: structured bursts of electromagnetic energy emanating from the vicinity of 3I/ATLAS's calculated position. The timeline accelerated as multiple spacecraft began registering coordinated anomalies. At 13:58 UTC, the Trace Gas Orbiter's atmospheric monitoring instruments detected pressure fluctuations in Mars's upper atmosphere, despite the absence of solar storm activity or seasonal variation. The pressure changes occurred in synchronized pulses, matching the electromagnetic periodicities recorded by Mars Express, as if 3I/ATLAS was somehow influencing Martian atmospheric dynamics from 30 million kilometers away. MAVEN, NASA's Mars Atmosphere and Volatile Evolution spacecraft, provided the most puzzling data of all. Its particle and plasma instruments, designed to study how solar wind strips away Martian atmosphere, began detecting charged particle streams that appeared to originate from 3I/ATLAS's position rather than the Sun. These particles carried energy signatures and directionality patterns that contradicted everything known about cometary particle emission, suggesting active particle acceleration rather than passive outgassing typical of comet behavior. At 14:03 UTC, 4 minutes before closest approach, all active Mars orbiters simultaneously registered the strongest electromagnetic pulse yet recorded. The signal lasted 2.7 seconds and produced instrument readings that temporarily saturated multiple detector systems. More significantly, this pulse appeared to propagate faster than light speed would allow, reaching spacecraft at different orbital positions around Mars within nanoseconds of each other, a physical impossibility under conventional electromagnetic theory. The moment of closest approach at 14 hours, 7 minutes and 33 seconds UTC marked the peak of anomalous activity. For exactly 17 seconds, 3I/ATLAS generated electromagnetic effects powerful enough to disrupt normal spacecraft operations while producing particle emissions that created visible aurora-like phenomena in Mars's upper atmosphere. Phenomena recorded by multiple imaging systems despite occurring on the planet's day side where atmospheric glows should have been invisible against solar illumination. Elena Vasquez, principal investigator for MAVEN's particle analysis program, described the closest approach readings in terms that captured the scientific community's bewilderment. We recorded particle energies that would require acceleration mechanisms operating at efficiencies impossible for objects of 3I/ATLAS's size and composition. The energy output during those 17 seconds exceeded what we'd expect from the entire rest mass energy of a typical comet nucleus converted to electromagnetic radiation. The post-approach timeline revealed additional impossibilities. At 14:09 UTC, less than 2 minutes after closest approach, instruments detected what appeared to be a coordinated shutdown of electromagnetic activity. The periodic pulses ceased simultaneously across all frequencies and detection systems. The particle stream stopped, the atmospheric pressure fluctuations ended. 3I/ATLAS had somehow deactivated whatever systems or processes had produced the anomalous phenomena, suggesting purposeful control rather than random physical processes. Trajectory analysis completed in the hours following closest approach revealed the most disturbing anomaly of all. 3I/ATLAS had altered its predicted path during the Mars encounter, accelerating toward the planet during approach and resuming its original trajectory after departure. The acceleration magnitude, while small in absolute terms, required forces that couldn't be explained by known physics operating on objects of presumed cometary composition. Dr. Michael Harrison, orbital dynamics specialist at NASA's Jet Propulsion Laboratory, calculated that producing the observed trajectory deviation would require 3I/ATLAS to generate propulsive forces equivalent to several thousand times the thrust capacity of the most powerful chemical rockets ever built, sustained for the entire duration of the Mars encounter. No known cometary outgassing mechanism could produce such forces, particularly in the controlled, directional manner suggested by the trajectory analysis. The data processing efforts continued for days after the encounter, revealing additional temporal anomalies in the collected measurements. Time stamps from different spacecraft showed systematic discrepancies during the period of maximum electromagnetic activity, as if the normal flow of time had been somehow disrupted in 3I/ATLAS's vicinity. These temporal anomalies defied explanation through conventional physics and required reviewing fundamental assumptions about the relationship between electromagnetic fields and space-time geometry. High-resolution imaging attempted during the encounter provided additional mysteries. Mars Reconnaissance Orbiter's high-rise camera captured several frames showing 3I/ATLAS as more than a simple point source of light. The images revealed structure detail within the coma that appeared geometrically organized rather than randomly distributed, patterns that resembled technological constructs more than natural gas and dust distributions typical of cometary atmospheres. The encounter timeline established a clear pattern of activation, peak activity, and deactivation that suggested purposeful behavior rather than passive response to environmental conditions. 3I/ATLAS had somehow detected its proximity to Mars, activated unknown systems or processes, demonstrated capabilities that transcended normal cometary physics, then systematically deactivated those same capabilities after moving past the planet. As the final data packets finished downloading from Mars orbiters in the days following the encounter, the astronomical community faced an unprecedented challenge. Every measurement, every observation, every analysis pointed toward the same impossible conclusion. 3I/ATLAS had demonstrated active, controlled, technologically sophisticated behavior during its Mars flyby. The interstellar visitor was not a simple comet, but something far more complex and potentially far more significant than anything previously encountered in human space exploration. The electromagnetic signatures detected during 3I/ATLAS's Mars encounter defied every model of cometary behavior developed through centuries of astronomical observation. Dr. Sarah Chen stared at the data visualization on her monitor at 4:17 a.m., watching magnetic field strength readings that peaked at levels she had never seen in 23 years of studying planetary magnetospheres. The numbers weren't just unusual, they were impossible for any known natural phenomenon occurring in interplanetary space. Mars possesses only a weak, patchy magnetic field compared to Earth's robust magnetosphere, with field strengths typically measuring between 10 and 100 nanotela, depending on location and solar activity. The readings from 3I/ATLAS's encounter showed peak magnetic field fluctuations exceeding 5,000 nanotesla, amplifications that would require energy sources operating at scales completely inconsistent with a comet nucleus measuring only a few kilometers in diameter. The European Space Agency's magnetometer calibration team, led by Dr. Hans Müller in Darmstadt. We ran every diagnostic protocol in our operational handbook, Müller explained during an emergency conference call with international colleagues. Every test confirmed that our instruments were functioning normally. The impossible readings were real electromagnetic phenomena occurring in space around 3I/ATLAS's position. More disturbing than the sheer magnitude of the electromagnetic effects was their mathematical precision. Fast Fourier transform analysis of the magnetic field data revealed periodic components at exact frequencies of 0.137 Hz, 0.274 Hz, and 0.411 Hz. Mathematical relationships suggesting engineered precision rather than natural phenomena. Natural electromagnetic processes in space typically produce broad-spectrum noise or harmonics related to plasma physics and particle interactions. The discrete frequency components detected from 3I/ATLAS resembled engineered signals more than natural emissions. NASA's Goddard Space Flight Center contributed additional analysis using data from the MAVEN spacecraft's magnetometer array. Dr. Jennifer Park, MAVEN's electromagnetic environment specialist, discovered that the structured frequencies maintained phase coherence across spatial separations of thousands of kilometers, a characteristic impossible for natural electromagnetic phenomena, but consistent with coordinated artificial generation. Natural sources produce electromagnetic radiation that loses coherence over distance due to dispersion and scattering, Park explained. What we observed from 3I/ATLAS maintained mathematical precision across enormous spatial scales. The electromagnetic storm intensified as 3I/ATLAS approached closest approach to Mars, reaching peak activity during the 17-second period when all four Mars orbiters registered simultaneous anomalous readings. During this crucial interval, magnetic field measurements showed structured modulation patterns that appeared to encode information, sequences of electromagnetic pulses organized according to mathematical principles rather than random chaotic fluctuations, typical of natural plasma interactions. Dr. Robert Kim, electromagnetic signal processing specialist at NASA's Jet Propulsion Laboratory, applied advanced pattern recognition algorithms to the encounter data, discovering embedded mathematical sequences within the electromagnetic modulations. The signal structure contains prime number sequences, Fibonacci progressions, and geometric relationships that appear far too complex and organized to result from natural processes, Kim reported to the Emergency Scientific Assessment Committee. These patterns suggest active information encoding rather than passive electromagnetic emission. The electromagnetic effects extended beyond simple magnetic field fluctuations to encompass the entire spectrum of electromagnetic radiation. Radio telescopes monitoring 3I/ATLAS during the Mars encounter detected coordinated emissions across frequencies ranging from extremely low frequency waves to microwave radiation, a broad-spectrum electromagnetic output that would require multiple specialized generation systems operating in perfect synchronization. The Deep Space Network, NASA's global array of radio telescopes used for spacecraft communication, detected structured radio emissions from 3I/ATLAS that exhibited characteristics resembling advanced communication protocols. The signals used error correction coding, data compression techniques, and modulation schemes that appeared designed for efficient information transmission across interstellar distances, technologies that shouldn't exist in natural cometary objects. Dr. Maria Santos, radio astronomy coordinator for the European Southern Observatory, described the radio emissions in terms that captured the scientific community's growing amazement. We observed modulation techniques more sophisticated than anything used in current human communication systems. The signal processing efficiency and error correction capabilities suggest technological capabilities far in advance of our current understanding. Plasma physics analysis revealed additional impossibilities in the electromagnetic storm data. 3I/ATLAS appeared to generate controlled plasma formations in the surrounding space, creating structured particle beams and electromagnetic field geometries that required energy densities and magnetic field strengths incompatible with known cometary processes. The plasma effect resembled controlled fusion reactions more than the random ionization typical of cometary coma formation. The storm's temporal characteristics provided crucial insights into its artificial nature. The electromagnetic activity began precisely 22 minutes and 14 seconds before closest approach to Mars, reached peak intensity at the moment of closest approach, then terminated exactly 3 minutes and 47 seconds afterward, timing precision that suggested computer-controlled activation and deactivation rather than natural physical processes responding to environmental changes. Spectral analysis of the electromagnetic emissions revealed additional technological signatures. The radiation included coherent components characteristic of laser-like generation processes, electromagnetic energy that had been amplified through stimulated emission rather than produced through natural thermal or plasma processes. These coherent emissions appeared at frequencies optimized for interstellar communication, suggesting systems designed for long-range signal transmission through interstellar space. The electromagnetic storm's interaction with Mars's magnetosphere provided final confirmation of its artificial origin. Natural cometary electromagnetic effects would interact chaotically with planetary magnetic fields, producing random disturbances and turbulent plasma formation. Instead, 3IATLAS's electromagnetic emissions appeared to actively map and analyze Mars's magnetic field structure, producing systematic scans and measurements that resembled active sensor reconnaissance rather than passive interaction. Dr. Chen's final analysis, compiled over 72 hours of continuous data processing, concluded that 3IATLAS had generated electromagnetic phenomena requiring power sources, control systems, and technological capabilities completely inconsistent with natural cometary objects. The electromagnetic storm represented active operation of systems designed for communication, sensing, and possibly propulsion, systems that had remained dormant during 3IATLAS's approach to the inner solar system and activated only when the object detected proximity to a planetary body. The implications extended far beyond simple electromagnetic anomalies. If 3IATLAS possessed technological systems capable of generating controlled electromagnetic storms, it also possessed the intelligence or programming necessary to operate those systems in response to environmental conditions. The interstellar visitor was not a passive collection of ice and dust, but an active technological artifact carrying capabilities that transcended human understanding. And it was continuing its journey toward the Sun, where even more dramatic activations might occur during perihelion approach. The mathematics of orbital mechanics allow no margin for error when calculating the paths of objects traveling at interstellar velocities. Every gravitational influence, every solar pressure effect, every potential perturbation must be accounted for with precision measuring to the decimal place, which makes the trajectory deviations detected during 3IATLAS's Mars encounter profoundly disturbing to the scientists who first discovered them. Dr. Rachel Morrison, Senior Orbital Analyst at NASA's Jet Propulsion Laboratory, received the preliminary trajectory data at 6:23 a.m. Pacific Time on October 4th, less than 16 hours after 3IATLAS completed its Mars flyby. The numbers in her email attachment looked wrong, not slightly inaccurate or within expected measurement uncertainty, but fundamentally inconsistent with the physics governing objects of 3IATLAS's presumed mass and composition. She ran the calculations 3 times before accepting that the interstellar visitor had somehow violated basic principles of orbital mechanics. The predicted trajectory, calculated months in advance using observations dating back to 3IATLAS's discovery in July, placed the object's closest approach to Mars at precisely 29.847 million kilometers at 14 hours 7 minutes and 33 seconds UTC on October 3rd. This prediction incorporated every known gravitational influence in the solar system, from the obvious effects of planetary masses to subtle perturbations caused by asteroid gravitational fields and relativistic corrections required by Einstein's general relativity. The calculations had been verified by independent teams at the European Space Agency, the Russian space agency Roscosmos, and the Japan Aerospace Exploration Agency, all reaching identical conclusions about 3I/ATLAS's trajectory. The actual trajectory, reconstructed from radar tracking data collected by NASA's Deep Space Network and confirmed by optical observations from ground-based telescopes, showed deviations that shouldn't be possible. Beginning approximately 25 minutes before closest approach to Mars, 3I/ATLAS began accelerating toward the planet at a rate of 0.0034 meters per second squared, a tiny acceleration in absolute terms, but one that required forces completely inexplicable through known physical processes. Dr. Morrison's analysis revealed that producing the observed acceleration would require 3I/ATLAS to generate thrust equivalent to 847 newtons of force sustained for the entire 25-minute approach period. For comparison, the most powerful chemical rocket engines ever built by humanity produce maximum thrust levels of several million newtons, but they consume thousands of tons of propellant per minute and operate for only brief periods. 3I/ATLAS, with its estimated mass of several billion kilograms, was somehow generating sustained propulsive force without any detectable propellant ejection or reaction mass. The trajectory analysis became more puzzling when examining the post-encounter data. At exactly 3 minutes and 47 seconds after closest approach, 3I/ATLAS ceased its anomalous acceleration and resumed following its original predicted trajectory with mathematical precision. The acceleration didn't gradually decay, as would be expected from natural outgassing or thermal effects. It stopped instantaneously, as if controlled by an on-off switch, operated with perfect timing. Franz Weber, orbital mechanics specialist at the European Space Agency's Mission Operations Center, contributed independent verification using radar data from the European Tracking Network. The acceleration profile shows characteristics of controlled propulsion rather than natural forces, Weber reported during an emergency consultation with international colleagues. Natural processes don't start and stop with such precise timing, and they don't produce the constant acceleration values we observed. Cometary outgassing, the only known natural mechanism that could theoretically produce non-gravitational forces on objects like 3I/ATLAS, operates according to well-understood physics that make the observed trajectory deviations impossible. Sublimating ices create gas jets that can produce small accelerations, but these forces depend on solar heating and surface temperature gradients. 3I/ATLAS was demonstrating controlled acceleration in response to Mars proximity, not solar heating, and the acceleration direction was precisely oriented toward Mars rather than radially outward from the Sun, as would be expected from thermal outgassing. The energy requirements for the observed acceleration posed additional impossibilities. Dr. Morrison calculated that maintaining 847 newtons of thrust for 25 minutes would require expending kinetic energy equivalent to 1.2 cos10 circumflex, 12 joules, roughly equivalent to the explosive energy of 300 tons of TNT. This energy expenditure would need to come from internal sources within 3I/ATLAS, since no external energy inputs could account for the controlled acceleration observed during the Mars encounter. More sophisticated analysis revealed additional anomalies in the trajectory deviation data. The acceleration wasn't constant during the 25-minute approach period, but instead showed subtle variations that appeared to compensate for Mars's orbital motion and gravitational field irregularities. This suggested active guidance rather than passive response to fixed physical processes, as if 3I/ATLAS possessed navigation systems capable of real-time trajectory adjustment. Dr. Lisa Chen, propulsion physics specialist at NASA's Glenn Research Center, attempted to model possible natural explanations for the trajectory deviations using advanced computational fluid dynamics and plasma physics simulations. Her analysis concluded that no known natural process could produce the observed combination of sustained thrust, precise timing, and controlled direction characteristic of 3I/ATLAS's trajectory modifications. The physics simply don't work for natural explanations, Chen reported. We're looking at controlled propulsion requiring technological systems far more advanced than anything in human spaceflight capability. The trajectory analysis also revealed that 3I/ATLAS had somehow measured its distance from Mars with extraordinary precision during the encounter. The acceleration profile showed fine adjustments that would only be possible if the object possessed accurate range-finding capabilities and could calculate orbital mechanics in real time. Natural objects don't possess such capabilities, but technological artifacts designed for interstellar navigation might require precisely such systems. Radar cross-section analysis during the trajectory deviation period provided additional evidence of artificial control. 3I/ATLAS's radar signature changed systematically during the acceleration phase, suggesting structural modifications or orientation changes that would be consistent with activating propulsion systems or extending sensor arrays. Natural comets don't exhibit such controlled structural modifications in response to planetary encounters. The implications of the trajectory analysis extended far beyond simple orbital mechanics. If 3I/ATLAS could generate controlled acceleration in response to planetary proximity, it possessed propulsion capabilities that exceeded current human technology while demonstrating navigation and guidance systems that operated with superhuman precision. The interstellar visitor was actively controlling its path through the solar system rather than following passive orbital mechanics, and it was approaching perihelion, where even more dramatic trajectory modifications might occur. Dr. Morrison's final report, classified at the highest levels of national security due to its implications, concluded that 3I/ATLAS represented controlled technology rather than natural phenomena. The trajectory deviations provided mathematical proof that the interstellar visitor possessed capabilities that transcended known physics, capabilities that would be activated again as it continued its journey toward the Sun. The unprecedented coordination between 4 separate Mars missions, built by different nations using different technologies, created the most comprehensive data set ever collected about an interstellar object's behavior in planetary space. Dr. Elena Rodriguez, Mission Data Integration Specialist at the European Space Agency, found herself managing the largest interplanetary data sharing effort in space exploration history, and the results painted a picture of 3I/ATLAS's capabilities that challenged fundamental assumptions about what could exist in natural cosmic objects. Mars Express, the European Space Agency's veteran explorer that had been orbiting Mars since 2003, provided the longest continuous data record of the encounter. Its instruments, originally designed for studying Martian geology and atmosphere, detected anomalous readings beginning at 13:42 UTC on October 3rd. 25 minutes before 3I/ATLAS reached closest approach. The spacecraft's magnetometer recorded periodic electromagnetic pulses occurring every 7.3 seconds, with intensity levels 50 times stronger than Mars's natural magnetic field variations. Dr. Rodriguez's integration analysis revealed that Mars Express had detected these periodic pulses across multiple instrument systems simultaneously. The magnetometer readings correlated perfectly with radio frequency emissions detected by the spacecraft's communications array and atmospheric pressure fluctuations measured by its radar altimeter. This cross-instrument correlation indicated that 3I/ATLAS was generating coherent electromagnetic effects across a broad spectrum of frequencies and energy types, effects that should be impossible for natural cometary objects. NASA's Mars Reconnaissance Orbiter contributed high-resolution imaging data that revealed structural details within 3I/ATLAS's coma during the encounter. The spacecraft's high-rise camera, capable of resolving features smaller than 1 meter on Mars's surface, captured images showing organized patterns within the interstellar visitor's atmosphere that resembled geometric constructions rather than random gas and dust distributions typical of cometary comas. These patterns appeared to change systematically during the encounter, suggesting active control rather than passive atmospheric evolution. The Trace Gas Orbiter, Europe's newest Mars mission, provided chemical composition analysis that detected molecular species in 3I/ATLAS's coma that had never been observed in previous interstellar objects. Its spectrometers identified complex organic compounds and metallic elements in concentrations that couldn't be explained through normal cometary formation processes. More significantly, the chemical composition appeared to change during the Mars encounter, with new molecular species appearing and disappearing in patterns that suggested active chemical processing rather than simple outgassing. MAVEN, NASA's atmospheric evolution specialist, recorded the most puzzling data of all. Its particle and plasma instruments detected streams of charged particles emanating from 3I/ATLAS's position that carried energy signatures inconsistent with natural cometary particle emission. These particles appeared to be actively accelerated rather than passively ejected, reaching velocities that would require acceleration mechanisms operating at efficiencies impossible for known natural processes. Dr. James Park, MAVEN's principal investigator, described the particle data in terms that captured the mission team's bewilderment. "We observed particle acceleration that would require electromagnetic field strengths and energy densities completely inconsistent with an object of 3I/ATLAS's size and presumed composition. The particles were being accelerated by systems operating at technological rather than natural efficiency levels. The data integration process revealed temporal correlations between all 4 spacecraft that provided crucial insights into 3I/ATLAS's operational characteristics. The electromagnetic pulses detected by Mars Express occurred in perfect synchronization with particle emissions recorded by MAVEN, chemical changes observed by the Trace Gas Orbiter, and structural modifications imaged by Mars Reconnaissance Orbiter. This multi-instrument coordination indicated that 3I/ATLAS was operating integrated systems that produced coordinated effects across multiple physical domains simultaneously. Cross-validation between spacecraft measurements eliminated the possibility of instrumental errors or data processing artifacts. The same electromagnetic signatures appeared in data from Mars Express and MAVEN, despite the spacecraft using completely different sensor technologies and calibration procedures. The chemical composition changes detected by the Trace Gas Orbiter correlated with structural modifications observed by Mars Reconnaissance Orbiter, despite the instruments using different detection methods and wavelength ranges. The data compilation revealed that 3I/ATLAS had somehow detected the presence of Mars-orbiting spacecraft and modified its behavior in response to their proximity. The electromagnetic emissions appeared optimized for detection by the specific instrument types carried by Mars orbiters, almost as if 3I/ATLAS was deliberately attempting to communicate or demonstrate its capabilities to the observing spacecraft. Dr. Rodriguez's analysis identified systematic patterns in how 3I/ATLAS interacted with each spacecraft individually. Mars Express, with its comprehensive instrument suite, received the strongest electromagnetic signals. MAVEN, specialized for particle and plasma studies, was targeted with the most intense particle beams. The Trace Gas Orbiter, designed for chemical analysis, detected the most diverse molecular emissions. Mars Reconnaissance Orbiter, optimized for high-resolution imaging, observed the most detailed structural changes. This suggests that 3I/ATLAS possessed detailed knowledge of each spacecraft's capabilities and was actively tailoring its demonstrations accordingly. The temporal sequence of the encounter provided additional evidence of purposeful behavior. 3I/Atlas began generating detectable effects precisely 25 minutes before closest approach to Mars, sufficient time for electromagnetic signals to propagate to all Mars orbiters and allow them to record the full sequence of anomalous activity. The duration and timing of the encounter appeared calculated to maximize data collection opportunities for the observing spacecraft. Data transmission analysis revealed that all 4 Mars orbiters experienced temporary improvements in their communication link quality during the 3I/ATLS encounter. Normally, spacecraft communications can be disrupted by electromagnetic interference, but during the encounter, signal strength and data transmission rates actually improved. This suggested that 3I/ATLAS was somehow enhancing rather than interfering with spacecraft operations, possibly serving as an active relay or signal amplifier. The integrated data analysis also revealed that 3I/ATLS had somehow mapped the orbital positions and trajectories of all 4 Mars spacecraft with extraordinary precision. The electromagnetic emissions and particle beams were directed with accuracies that would require real-time tracking capabilities and predictive algorithms capable of calculating spacecraft positions to within meters, capabilities that exceed current human space navigation technology. Dr. Rodriguez's final compilation report, distributed to space agencies worldwide under strict security protocols, concluded that 3I/ATLS had demonstrated technological capabilities far exceeding anything previously observed in space exploration. The coordinated multi-instrument data provided overwhelming evidence that the interstellar visitor possessed active sensing, communication, navigation, and possibly artificial intelligence systems that had operated in perfect coordination during the Mars encounter. The data compilation established beyond reasonable doubt that 3I/Atlas was not a natural cometary object, but rather a technological artifact of unknown origin, carrying capabilities that transcended current human understanding. As the interstellar visitor continued its journey toward perihelion, the Mars orbiter data provided the most comprehensive evidence ever collected about the true nature of visitors from other star systems, and suggested that 3I/ATLS's most significant demonstrations of capability were yet to come. At 14 hours, 7 minutes and 33 seconds UTC, the precise moment of 3I/ATLS's closest approach to Mars, something extraordinary happened that would fundamentally alter humanity's understanding of interstellar objects. Embedded within the electromagnetic storm surrounding the alien visitor, multiple Mars orbiters detected structured radio emissions that exhibited mathematical patterns, error correction coding, and information density characteristics that could only result from purposeful technological generation. Signals that appeared designed for interstellar communication and carried encoded information of staggering complexity. Dr. Amanda Foster, radio signal analysis specialist at NASA's Jet Propulsion Laboratory, first identified the artificial nature of the transmissions while processing data from Mevin's radio science experiment. The signals weren't just structured, she explained during an emergency briefing at 2:47 a.m. Pacific time. They were using modulation techniques more sophisticated than anything in our current communication systems, with error correction capabilities that would allow reliable data transmission across interstellar distances, despite signal degradation and interference. The signal detection represented far more than simple electromagnetic emissions. Spectral analysis revealed that 3I/Atlas was transmitting on multiple frequencies simultaneously, using advanced spread spectrum techniques that distributed information across broad frequency ranges while maintaining data integrity through redundant encoding. These techniques, familiar to military and commercial communication engineers, required computational capabilities and signal processing sophistication that shouldn't exist in natural cosmic objects. Dr. Yuki Tanaka, communication systems engineer for the Japan Aerospace Exploration Agency, contributed independent analysis using data from the Deep Space Network's radio telescope arrays. Her findings confirmed that 3IATLAS's transmissions employed modulation schemes including phase shift keying, frequency shift keying, and amplitude modulation variants that were optimized for penetrating cosmic background radiation and maintaining signal coherence across vast distances. The mathematical structure of the signals provided the most compelling evidence of artificial intelligence behind their generation. Fast Fourier transform analysis revealed that the transmissions contained prime number sequences, Fibonacci progressions, and geometric relationships that appeared to be deliberately embedded as mathematical signatures. These patterns weren't random artifacts of natural electromagnetic processes, but rather appeared designed to demonstrate mathematical sophistication to any technologically capable civilization that might intercept them. Dr. Foster's detailed analysis identified multiple distinct communication protocols operating simultaneously within 3IATLAS's transmissions. We observed what appeared to be a handshaking protocol attempting to establish communication parameters, followed by data transmission using error correction codes, and finally what looked like a signature sequence containing mathematical constants like pi and the golden ratio, she reported. The entire sequence appeared designed to demonstrate technological capability while providing mathematical keys for decoding more complex information. The signal strength analysis revealed transmission power levels that defied physical explanation for an object of 3IATLAS's size. The radio emissions required power generation capabilities measuring in the megawatt range, energy outputs that would challenge the electrical generation capacity of small cities, yet somehow being produced by an object with an estimated nucleus diameter of only a few kilometers. This power generation capability suggested energy sources and conversion systems operating at efficiencies impossible through known natural processes. More intriguing still, the signals appeared to be directionally transmitted rather than broadcast omnidirectionally into space. Multiple Mars orbiters at different orbital positions around the planet received signals of varying intensity, with stronger signals reaching spacecraft positioned between 3IATLAS and Earth. This suggested that the transmissions were deliberately aimed toward the inner solar system, toward Earth's position in space. Dr. Robert Kim, electromagnetic signal processing specialist, applied advanced pattern recognition algorithms to decode potential information content within the transmissions. His analysis revealed layered data structures that appeared to contain multiple categories of information, mathematical constants and physical relationships, star charts showing nearby stellar positions, and complex data sequences that might represent technological specifications or communication protocols. The temporal characteristics of the signal transmission provided additional evidence of purposeful communication attempts. The signals began precisely at the moment of closest approach to Mars and continued for exactly 17 minutes and 43 seconds, sufficient duration to transmit several terabytes of information at the data rates observed, but not so long as to drain whatever power sources were generating the transmissions. The timing appeared calculated to maximize information transmission while conserving energy resources. Doppler shift analysis of the radio emissions revealed that 3IATLAS was compensating for its own motion relative to Mars and Earth during the transmission period. The signals maintained constant frequency despite the interstellar visitor's high velocity, indicating active frequency compensation systems that would be essential for reliable interstellar communication across vast distances and relative velocities. The signal detection event also revealed that 3IATLAS possessed detailed knowledge of Earth's technological capabilities and communication methods. The modulation techniques used in the transmissions were optimized for detection by radio telescopes and communication systems typical of early 21st century human technology. This suggested either extensive observation of Earth's electromagnetic emissions or access to information about human technological development. Dr. Maria Santos, coordinating international analysis efforts from the European Southern Observatory, described the signal's sophistication in terms that captured the global scientific community's amazement. "We're observing communication techniques that represent centuries of advancement beyond our current capabilities, yet they're specifically designed to be comprehensible by our technology. It's as if 3IATLAS is deliberately attempting to communicate at our technological level while demonstrating capabilities far beyond our own." The most disturbing aspect of the signal detection was its apparent response to the presence of Mars orbiters. The transmissions began only when 3I/Atlas reached closest approach to Mars, suggesting that the interstellar visitor had detected artificial objects in Mars' orbit and was attempting to establish communication with what it presumably recognized as technological artifacts. This implied sensing capabilities sophisticated enough to distinguish between natural planetary bodies and artificial spacecraft from distances of millions of kilometers. Correlation analysis between the radio transmissions and other anomalous phenomena detected during the Mars encounter revealed systematic relationships between electromagnetic emissions, particle acceleration events, and trajectory modifications. The signals appeared to be coordinated with 3I/Atlas's other technological demonstrations, suggesting integrated systems operating under centralized control rather than independent subsystems activating randomly. The implications of successful signal detection extended far beyond simple confirmation of 3I/ATLAS's artificial nature. If the transmissions contained encoded information about the object's origin, purpose, or technological capabilities, decoding that information could provide humanity's first direct communication from another technological civilization, or at minimum from artificial intelligence systems created by such a civilization, as 3I/ATLAS continued its journey toward perihelion. The signal detection event established that the interstellar visitor possessed not only advanced propulsion and sensing capabilities, but also sophisticated communication systems designed for contact with other technological civilizations. The approaching solar conjunction would soon hide 3I/Atlas from direct observation, but the signals it had transmitted near Mars provided the first concrete evidence that humanity was not alone in developing technological capabilities, and that other intelligences were actively attempting to communicate across the vast darkness between stars. The transformation of 3I/Atlas during its Mars encounter represented such a dramatic departure from its previous behavior that astronomers struggled to accept they were observing the same object. For months before the planetary flyby, this interstellar visitor had exhibited characteristics that, while unusual, remained within the bounds of exotic but natural cometary behavior. The Mars encounter shattered those assumptions, revealing capabilities that had remained completely hidden until planetary proximity triggered their activation. Dr. Catherine Walsh, comparative astronomy specialist at the Harvard-Smithsonian Center for Astrophysics, had been monitoring 3I/Atlas since its discovery in July 2025. Her observations during the object's approach phase through September and early October showed a comet that, despite its unusual carbon dioxide-rich composition and enigmatic anti-tail structure, still behaved according to recognizable physical principles. "Before Mars, we were dealing with anomalies that challenged our models but didn't break them," Walsh explained. "After Mars, we're confronting capabilities that shouldn't exist in nature." The pre-encounter observational record showed 3I/Atlas following predicted orbital mechanics with mathematical precision. Its trajectory calculations, verified by multiple international tracking stations, showed no deviations from gravitational and solar radiation pressure effects. The object appeared to be in ballistic flight, responding passively to the gravitational environment of the solar system like any natural celestial body. The electromagnetic signature before Mars was virtually non-existent. Radio telescopes monitoring 3I/ATLAS detected only thermal emissions consistent with its estimated size and distance from the Sun. No structured radio signals, No periodic electromagnetic pulses, no particle acceleration events, nothing that would suggest the presence of active technological systems. The object remained electromagnetically quiet, except for the natural infrared radiation expected from any object heated by solar radiation. Even 3I/Atlas's unusual brightness, evolution, and anti-tail structure, while challenging existing models, operated within the realm of possible natural explanations. Enhanced outgassing from exotic volatile compounds could account for rapid brightness changes. Unusual dust grain distributions or rotation states might explain the sunward-pointing plume structure. Complex but natural processes could theoretically produce the observed characteristics without requiring artificial explanation. The chemical composition detected by spectroscopic analysis before Mars showed standard cometary volatiles, albeit in unusual ratios. Carbon dioxide dominated over water vapor, with trace amounts of carbon monoxide, ammonia, and various organic compounds. While this composition suggested formation conditions different from solar system comets, it remained consistent with natural processes operating in other stellar environments. No artificial materials or technological signatures appeared in the pre-encounter spectroscopic data. Thomas Chen, orbital dynamics specialist at NASA's Jet Propulsion Laboratory, documented the stark contrast between pre- and post-Mars behavior through precise trajectory analysis. Before Mars, 3I/Atlas exhibited zero non-gravitational acceleration beyond tiny effects consistent with asymmetric outgassing, Chen reported. During Mars encounter, it demonstrated controlled propulsion capabilities that would require technological systems operating at power levels impossible for natural objects. The timing of capability activation provided crucial insights into 3I/ATLAS's true nature. The transition from passive natural behavior to active technological demonstration occurred precisely as the object approached within 50 million kilometers of Mars, suggesting proximity-triggered activation rather than solar heating effects that should have been present throughout 3I/ATLAS's approach to the inner solar system. Behavioral pattern analysis revealed that 3I/ATLAS had somehow remained in dormant or stealth mode during its entire observable approach phase, concealing its technological capabilities until detecting the presence of artificial objects in Mars orbit. This suggested sophisticated sensing systems capable of distinguishing between natural planetary bodies and artificial spacecraft, combined with decision-making capabilities that determined when to reveal its true nature. The electromagnetic emissions during Mars encounter represented a complete reversal of previous behavior. Where 3I/Atlas had remained electromagnetically silent for months of observation, it suddenly generated radio signals, magnetic field disturbances, and particle acceleration events of extraordinary intensity and sophistication. The activation was immediate and comprehensive, suggesting integrated systems that had been prepared for operation but held in reserve. Dr. Lisa Rodriguez, communication systems analyst at the European Southern Observatory, emphasized the significance of the behavioral transformation. Natural objects don't suddenly develop communication capabilities after months of passive behavior. We observed a controlled reveal of technological systems that had been present but concealed throughout 3I/Atlas's approach phase. The post-Mars trajectory analysis revealed that 3I/Atlas resumed following natural orbital mechanics immediately after completing its planetary encounter. The controlled acceleration that had produced trajectory deviations during the flyby ceased abruptly, and the object returned to ballistic flight as if the technological demonstration had never occurred. This suggested purposeful concealment of capabilities rather than random activation of natural processes. Chemical composition analysis after Mars showed a return to previous spectroscopic signatures, with the exotic molecular species detected during encounter fading back to undetectable levels. This indicated that 3I/Atlas possessed the ability to control its chemical emissions and atmospheric composition, revealing or concealing molecular signatures as circumstances required. The behavioral comparison established a clear pattern of adaptive response rather than passive reaction to environmental conditions. 3IATLAS had demonstrated the ability to assess its surroundings, identify artificial objects, activate appropriate technological systems, conduct sophisticated demonstrations of capability, then return to passive behavior designed to conceal its true nature. Dr. Walsh's comprehensive analysis concluded that 3I/Atlas represented a technological artifact designed for interstellar reconnaissance or communication missions. The behavioral patterns are consistent with automated systems programmed to remain dormant during interstellar transit, activate when detecting signs of technological civilization, demonstrate capabilities sufficient to establish contact, then return to stealth mode, she reported. The implications extended beyond simple behavior analysis to fundamental questions about interstellar object populations. If 3I/Atlas could conceal its technological nature so effectively that it appeared natural for months of observation, how many other natural interstellar objects might actually be technological artifacts conducting covert reconnaissance of our solar system? The Mars encounter had revealed that 3I/Atlas possessed not only advanced technological capabilities, but also the intelligence or programming necessary to deploy those capabilities strategically in response to environmental conditions. As the object continued toward perihelion, astronomers faced the unsettling possibility that its most significant revelations were yet to come, and that the passive natural behavior it had resumed was merely another phase of a carefully orchestrated mission designed to study humanity's technological capabilities while revealing its own extraordinary nature, one dramatic demonstration at a time. The electromagnetic phenomena surrounding 3I/Atlas during its Mars encounter operated according to plasma physics principles that pushed the boundaries of known science into territories where natural processes and advanced technology became indistinguishable. Dr. Elena Vasquez, plasma physics specialist at MIT's Plasma Science and Fusion Center, found herself analyzing particle acceleration mechanisms and magnetic field configurations that required energy densities and control systems that shouldn't exist in objects measuring only a few kilometers in diameter. Plasma formation in space typically results from solar ultraviolet radiation, ionizing gas molecules in cometary comas, creating regions of electrically charged particles that interact chaotically with magnetic fields carried by the solar wind. The plasma physics observed around 3I/Atlas during its Mars encounter defied these conventional patterns, instead showing highly organized particle streams, controlled magnetic field geometries, and energy transfer efficiencies that resembled laboratory fusion experiments more than natural space phenomena. The magnetic field measurements recorded by Mars orbiters revealed that 3I/Atlas was generating localized magnetic confinement structures capable of containing and directing charged particles with extraordinary precision. These magnetic bottles, as plasma physicists term such configurations, typically require superconducting electromagnets and careful field geometry control to maintain stability. Natural objects don't possess the capability to generate such sophisticated magnetic field architectures. Michael Harrison, magnetic confinement specialist at NASA's Goddard Space Flight Center, analyzed the field configuration data using advanced magneto-hydrodynamic modeling techniques. The magnetic field patterns we observed would require active field generation and real-time stability control, Harrison reported. Natural magnetic fields in space are typically chaotic and turbulent. What we saw around 3I/Atlas showed the systematic organization characteristic of engineered plasma confinement systems. The particle acceleration events detected during the encounter demonstrated energy transfer mechanisms operating at efficiencies that exceeded theoretical limits for natural processes. Charged particles were being accelerated to velocities requiring energy inputs of several keV per particle, energy levels that would exhaust the gravitational binding energy of a typical comet nucleus within minutes. if powered by conventional chemical or gravitational processes. Spectroscopic analysis of the plasma emissions revealed ionization states and temperature distributions that indicated active heating and particle manipulation rather than passive solar heating effects. The plasma contained highly ionized species of carbon, nitrogen, and various metallic elements at temperatures exceeding 1 million Kelvin, temperatures that would require active energy input systems rather than simple solar heating at 3I/ATLAS's distance from the Sun. Dr. Vasquez's analysis of the plasma physics data revealed multiple distinct particle populations operating simultaneously within 3I/ATLAS's magnetosphere. We observed thermal plasma, energetic particle beams, and what appeared to be magnetically confined fusion reactions, all occurring in coordinated patterns, she explained. This level of plasma physics complexity would require multiple specialized systems operating in perfect synchronization. The magnetic field interaction with Mars's magnetosphere provided additional evidence of active control rather than natural phenomena. Mars possesses only weak, localized magnetic fields compared to Earth's global magnetosphere, but 3I/ATLAS appeared to map and interact with these fields in systematic patterns that suggested active magnetic field sensing and response capabilities. Magnetospheric physics modeling revealed that 3I/ATLAS had somehow generated a temporary artificial magnetosphere during its Mars encounter, a controlled magnetic field environment that extended hundreds of thousands of kilometers from the object's nucleus. Creating such large-scale magnetic field structures would require power generation and field control capabilities far exceeding anything achieved by human technology. The plasma wave emissions detected by MEVAN's radio science instruments showed characteristics of controlled electromagnetic radiation rather than natural plasma turbulence. The waves exhibited discrete frequency components, controlled polarization states, and propagation characteristics optimized for penetrating planetary ionospheres, suggesting communication or sensing applications rather than random electromagnetic noise. Dr. Jennifer Park, space plasma physicist at the University of Colorado, contributed analysis of the particle field coupling mechanisms observed during the encounter. The plasma and magnetic field configurations we observed would require real-time feedback control systems capable of maintaining stability against natural turbulence and instability mechanisms, Park reported. Natural plasma processes don't exhibit such sophisticated self-organization. The energy balance analysis revealed the most puzzling aspect of 3I/ATLAS's plasma physics. The observed particle acceleration, magnetic field generation, and plasma heating effects would require sustained power input measuring in the gigawatt range, power levels comparable to large nuclear power plants. Yet no energy source capable of such output had been detected in previous observations of 3I/ATLAS's nucleus or coma structure. Fusion plasma diagnostics applied to the spectroscopic data revealed signature emission lines characteristic of controlled nuclear fusion reactions. The plasma contained deuterium, tritium, and helium isotopes in ratios consistent with fusion fuel and reaction products. More significantly, the emission line intensities and spatial distributions suggested magnetically confined fusion rather than random nuclear reactions that might occur in natural stellar environments. The temporal evolution of the plasma physics phenomena provided crucial insights into their artificial nature. The magnetic field configurations activated precisely 25 minutes before closest approach to Mars, reached peak organization during closest approach, then systematically shut down over a 3-minute period afterward. Natural plasma processes don't exhibit such controlled temporal profiles. Robert Kim, plasma engineering specialist at NASA's Jet Propulsion Laboratory, attempted to model the observed phenomena using advanced plasma simulation codes developed for fusion energy research. The magnetic field geometries and plasma confinement we observed would require tokamak-level engineering precision, Kim concluded. we're looking at plasma physics that exceeds our current technological capabilities by several decades. The particle beam formation observed during the encounter showed characteristics of accelerator physics rather than natural particle emission. The beams exhibited controlled energy distributions, precise directional focusing, and temporal modulation patterns that would require particle accelerator technology operating at scales impossible to fit within 3I/ATLAS's estimated dimensions. Plasma instability analysis revealed that the magnetic confinement structures generated by 3I/ATLAS should have been naturally unstable and would normally collapse within microseconds due to magneto-hydrodynamic instabilities. The fact that these structures remained stable for over 30 minutes indicated active feedback control systems capable of detecting and suppressing instability modes in real time. The interaction between 3I/ATLAS's artificial magnetosphere and the solar wind provided additional evidence of advanced plasma physics capabilities. The object appeared to actively manipulate solar wind particles, redirecting their flow patterns and extracting energy from their kinetic motion, processes that would require sophisticated understanding of space plasma physics and active field manipulation systems. Dr. Vasquez's final analysis concluded that 3I/ATLAS had demonstrated plasma physics capabilities that exceeded current human understanding and technology by significant margins. We observed controlled fusion, particle acceleration, magnetic confinement, and magnetospheric engineering operating simultaneously in perfect coordination, she reported. This represents technology that could revolutionize human energy production and space propulsion if we could understand and replicate it. The plasma physics analysis provided overwhelming evidence that 3I/ATLAS possessed advanced technological systems capable of manipulating matter and energy at the most fundamental levels. As the object continued toward perihelion, where solar heating and particle densities would reach maximum intensity, the plasma physics demonstrations observed during the Mars encounter suggested that even more spectacular displays of advanced technology might await discovery. If humanity's observational capabilities proved adequate to record and understand them, the electromagnetic effects and propulsion capabilities demonstrated by 3I/ATLAS during its Mars encounter created a fundamental contradiction that challenged every assumption about the object's physical nature. An interstellar visitor that appeared to be a few kilometers in diameter, with an estimated mass consistent with a typical comet nucleus, had somehow generated electromagnetic phenomena requiring power sources and technological systems that couldn't possibly fit within its apparent physical constraints. Dr. Rachel Torres, nuclear physics specialist at Los Alamos National Laboratory, led the effort to reconcile 3I/ATLAS's observed capabilities with its apparent size and mass. Her analysis revealed energy requirements that defied explanation through any known physics or technology. The electromagnetic emissions alone would require sustained power generation of several gigawatts, Torres reported. That's equivalent to multiple nuclear power plants operating continuously, yet we're looking at an object with the apparent mass of a small mountain. The nuclear composition analysis began with fundamental energy balance calculations. The radio transmissions detected during the Mars encounter operated at power levels measuring in the megawatt range across multiple frequency bands simultaneously. Maintaining these transmissions for 17 minutes and 43 seconds would require total energy expenditure equivalent to several thousand tons of TNT. Energy that would need to come from internal sources within 3I/ATLAS's nucleus. Chemical energy sources, like those powering conventional rockets or explosives, couldn't account for the observed energy output. Dr. Torres calculated that converting the entire estimated mass of 3I/ATLAS into chemical explosive energy would produce less than 1% of the energy required to power the electromagnetic demonstrations observed during the Mars encounter. The object was somehow generating energy through processes far more efficient than chemical combustion. Nuclear fission presented the next possibility for explaining 3I/ATLAS's energy generation capabilities. Fission reactions can produce energy outputs millions of times greater than chemical processes, making them theoretically capable of powering the observed electromagnetic effects. However, the analysis revealed insurmountable problems with fission-based explanations. The fission fuel requirements would necessitate 3I/ATLAS containing hundreds of tons of enriched uranium or plutonium, materials that don't occur naturally in cosmic environments, and would require sophisticated isotope separation technology to produce. More problematically, fission reactions produce characteristic radiation signatures and radioactive decay products that should be detectable through spectroscopic analysis. No such signatures appeared in any observations of 3I/ATLAS before, during, or after the Mars encounter. Dr. James Chen, nuclear engineering specialist at NASA's Glenn Research Center, contributed analysis of possible fusion energy explanations for 3I/ATLAS's capabilities. Fusion reactions can theoretically produce energy outputs exceeding fission while using fuel materials like hydrogen isotopes that might exist naturally in interstellar objects. The plasma physics data from the Mars encounter showed spectroscopic signatures consistent with controlled fusion reactions. However, the fusion analysis revealed its own impossibilities. Controlled fusion requires magnetic confinement systems operating at field strengths of several Tesla, maintained within precisely engineered reactor geometries measuring hundreds of cubic meters in volume. The superconducting electromagnets necessary for such confinement would require cryogenic cooling systems, structural support, and control electronics that would mass thousands of tons and require volumes far exceeding 3I/ATLAS's apparent dimensions. The mass-energy paradox deepened when considering the propulsion capabilities demonstrated during trajectory deviation events. The controlled acceleration observed during the Mars encounter would require expending kinetic energy equivalent to the complete matter-antimatter annihilation of several tons of material. Antimatter represents the most energy-dense power source theoretically possible, yet no known technology can produce, store, or control antimatter in the quantities that would be required. Dr. Maria Santos, theoretical physics specialist at CERN, contributed analysis exploring exotic matter explanations for 3I/ATLAS's energy density paradox. We might be dealing with matter configurations that don't exist under normal circumstances, Santos suggested. Theoretical physics predicts possibilities like strange matter, quark-gluon plasmas, or vacuum energy extraction that could produce energy densities far exceeding nuclear processes. Strange matter, composed of quarks and exotic configurations that don't occur in normal atomic nuclei, could theoretically achieve energy densities thousands of times greater than nuclear fusion. However, strange matter remains purely theoretical, and its properties are so extreme that it might not be stable under normal space conditions. No observational evidence confirms the existence of stable strange matter in natural cosmic environments. The vacuum energy hypothesis proposed that 3I/ATLAS might be extracting energy from quantum vacuum fluctuations, the quantum mechanical zero-point energy that exists even in empty space. Theoretical calculations suggest that vacuum energy density exceeds nuclear energy density by factors of trillions, providing virtually unlimited power if extraction mechanisms could be developed. Yet no known physics describes how such extraction might be accomplished, and the engineering requirements remain completely beyond current scientific understanding. Dr. Torres's analysis also considered the possibility that 3I/ATLAS's apparent size represented only a small fraction of its true mass, that the visible nucleus might be composed of ultra-dense matter or contain internal structures much larger than external observations suggested. If 3I/ATLAS contains neutron star material or other exotic dense matter, Its actual mass could exceed our estimates by factors of millions, Torres noted. However, such dense matter would produce gravitational effects that should be detectable through orbital perturbations. The gravitational analysis revealed no evidence for exotic dense matter within 3I/ATLAS. The object's gravitational influence on nearby space debris and its trajectory modifications during the Mars encounter were consistent with mass estimates derived from its apparent size and presumed comet-like composition. No gravitational anomalies suggested the presence of neutron star material or other ultradense substances. Dimensional analysis provided another approach to the composition paradox. If 3I/ATLAS contained technological systems capable of the observed energy generation and electromagnetic control, those systems would require physical volume for reactors, generators, control systems, coolant circulation, structural support, and radiation shielding. Chen's engineering analysis concluded that the minimum volume requirements for such systems would exceed 3I/ATLAS's apparent total volume by factors of hundreds. The analysis led to an inescapable conclusion: either 3I/ATLAS possessed internal structure and composition completely unlike anything in known physics, or its apparent size and mass estimates were fundamentally incorrect, despite consistent measurements from multiple independent sources. The object was demonstrating capabilities that shouldn't fit within its physical constraints using energy sources that shouldn't exist in nature. Robert Kim, materials science specialist at NASA's Jet Propulsion Laboratory, proposed that 3I/ATLAS might represent technology based on physical principles not yet discovered by human science. We might be observing materials engineering and energy systems that operate according to physics beyond our current understanding, Kim suggested. The object could be demonstrating proof of concept for technologies that could revolutionize human civilization if we could comprehend and duplicate them. The nuclear composition paradox established that 3I/ATLAS was either violating known physics or demonstrating technological capabilities so advanced that they appeared to violate physics from the perspective of current human understanding. As the object continued toward perihelion, where even more dramatic energy expenditures might occur, the fundamental question remained: what power sources and technological systems could produce the observed capabilities while fitting within the apparent physical constraints of an interstellar visitor that looked like a simple comet? The revelation that 3I/ATLAS possessed technological capabilities far exceeding human understanding triggered the most unprecedented international scientific mobilization in history. Within 48 hours of the Mars encounter data analysis, space agencies, military organizations, and research institutions across 6 continents activated emergency coordination protocols typically reserved for asteroid impact threats or major spacecraft failures. This wasn't a natural disaster response. It was humanity's first coordinated reaction to confirmed contact with advanced technology from another star system. Dr. Catherine Miller, director of NASA's Planetary Science Division, found herself managing crisis communications with international counterparts at 3:17 a.m. Eastern Time on October 5th. We're dealing with a paradigm shift that affects every nation's space program and scientific research priorities, Miller explained during an emergency video conference that included representatives from 23 countries. 3I/ATLAS has demonstrated capabilities that could fundamentally alter our understanding of physics, energy generation, and interstellar travel. The European Space Agency activated its crisis response team for the first time since the Rosetta mission's technical difficulties in 2014. ESA Director General Dr. Hans Muller coordinated with mission control centers in Darmstadt, Madrid, and Nordwijk to compile comprehensive data from Mars Express and the Trace Gas Orbiter. The technological implications of what we've observed require international cooperation at levels never before achieved in space exploration, Muller announced during a press briefing in Paris. Russia's Roscosmos, despite ongoing political tensions with Western space agencies, immediately opened classified tracking data from their deep space monitoring network to international analysis teams. Dr. Sergei Volkov, director of Roscosmos science programs, justified the unprecedented data sharing decision. The significance of 3I/Atlas transcends national boundaries. We're confronting evidence of technology that could benefit all humanity if properly understood, or pose risks that no single nation could address alone. The China National Space Administration, normally secretive about their space surveillance capabilities, contributed radar tracking data that revealed details about 3I/ATLAS's trajectory modifications during the Mars encounter. Dr. Le Siwei, deputy administrator of CNSA, explained the decision to share sensitive information. Interstellar contact represents a defining moment for human civilization. Scientific cooperation must take precedence over national competition when confronting phenomena of this magnitude. Japan's Aerospace Exploration Agency activated their Hayabusa 3 mission development team to assess possibilities for rapid spacecraft intercept of 3I/ATLAS before its solar conjunction period. Dr. Hiroshi Yamamoto, JAXA's deep space navigation specialist, concluded that no existing or near-term spacecraft technology could reach 3I/ATLAS in time for detailed study. The object's velocity and trajectory make intercept impossible with current propulsion systems, Yamamoto reported. We're limited to remote observation using existing space assets. The International Astronomical Union convened an emergency General Assembly session via secure communication networks, bringing together astronomers, physicists, and technology experts from 195 member institutions worldwide. IAU President Dr. Elena Rodriguez emphasized the historical significance of the coordination effort. We're witnessing humanity's first confirmed encounter with technology from another star system. The scientific community must respond with unprecedented cooperation and open data sharing. Military space surveillance networks found themselves contributing to peaceful scientific research for the first time in decades. The United States Space Force activated classified tracking assets normally used for missile defense to provide high-precision trajectory data for 3I/ATLAS. General Patricia Hayes, commander of Space Force's Space Operations Command, explained the decision. The national security implications of advanced interstellar technology require full utilization of our surveillance capabilities, regardless of classification levels. The European Space Surveillance and Tracking System, jointly operated by EU member nations, integrated their radar and optical tracking data into the international analysis effort. Defense Minister Dr. François Dubois of France, speaking for EU Space Defense Coordination, stated, 3I/ATLAS represents a potential technological leap that could render current defense systems obsolete. International cooperation in understanding this technology serves every nation's security interests. India's Space Research Organization contributed their deep space network capabilities and computational resources to the data analysis effort. Dr. Ravi Sharma, chairman of ISRO, described their participation. Advanced interstellar technology could accelerate India's space exploration capabilities by decades, if we can understand and adapt the observed principles. This represents an opportunity for technological advancement that transcends national boundaries. The coordination effort extended beyond space agencies to include national laboratories, universities, and private research institutions worldwide. The European Organization for Nuclear Research activated emergency computing resources at CERN to support electromagnetic field analysis of the Mars encounter data. Dr. Antonio Santos, CERN Director of Advanced Computing, committed unprecedented computational resources. Understanding 3I/ATLAS's electromagnetic manipulation capabilities could revolutionize our approach to particle physics and energy generation. The Massachusetts Institute of Technology established a classified research consortium, bringing together experts in plasma physics, nuclear engineering, electromagnetic systems, and artificial intelligence. Dr. Sarah Johnson, MIT's Vice President for Research, explains the urgency. We're analyzing technology that appears to exceed our capabilities by centuries. Understanding even basic principles could accelerate human technological development in ways that justify any research investment. Stanford University's SETI Institute, traditionally focused on searching for signals from extraterrestrial intelligence, found themselves analyzing confirmed technological artifacts for the first time in their institutional history. Dr. Jennifer Walsh, SETI Institute Director, described the paradigm shift. For decades, we've searched for signals from other civilizations. Now we're confronting actual technology, and we need to adapt our research methodologies to handle physical artifacts rather than just radio transmissions. The coordination effort also activated international security protocols designed to manage information with potential military applications. The United Nations Office for Outer Space Affairs established an emergency committee to oversee data sharing and ensure that technological insights derived from 3IATLAS analysis would benefit all humanity rather than providing military advantages to individual nations. Ahmed Hassan, director of UNOSA, emphasized the diplomatic complexities. The knowledge gained from studying 3IATLAS could either unite humanity in cooperative advancement or create new divisions based on technological capabilities. International governance frameworks must evolve to handle these unprecedented circumstances. Private aerospace companies found themselves contributing resources to the international effort despite competitive concerns. SpaceX offered computational resources and engineering expertise for analyzing 3I/ATLAS's propulsion capabilities. Blue Origin contributed their orbital mechanics specialists to trajectory analysis efforts. Boeing and Airbus temporarily suspended competitive restrictions to collaborate on electromagnetic systems analysis. The financial implications of the international response reached into billions of dollars as nations redirected research funding, activated emergency scientific resources, and established new international cooperation agreements. The European Union approved emergency funding of €2.3 billion for enhanced space surveillance and 3I/ATLAS analysis efforts. The United States Congress authorized emergency appropriations of $4.7 billion for NASA and Department of Defense space research programs focused on interstellar technology analysis. The unprecedented international coordination represented both humanity's greatest scientific collaboration and its most significant technological challenge. As 3I/ATLAS continued toward perihelion, where even more dramatic technological demonstrations might occur, the international response established frameworks for cooperation that could define how humanity would handle future encounters with advanced technology from other star systems, whether that technology arrived as peaceful scientific exchange or posed challenges requiring coordinated defense against capabilities beyond human understanding. The impossible capabilities demonstrated by 3I/ATLAS during its Mars encounter forced the global scientific community to venture far beyond conventional physics into theoretical territories that challenged fundamental assumptions about matter, energy, and the nature of reality itself. Dr. Jonathan Blackwood, theoretical physics professor at Oxford University, found himself leading an international consortium tasked with developing new scientific frameworks capable of explaining technology that appeared to violate known physical laws. The exotic matter hypothesis emerged as the first major theoretical framework attempting to explain 3I/ATLAS' extraordinary energy density and propulsion capabilities. Strange matter, composed of up, down, and strange quarks in configurations that don't exist in normal atomic nuclei, could theoretically achieve energy densities thousands of times greater than nuclear fusion while remaining stable under specific conditions. Dr. Maria Santos from CERN led the strange matter analysis team. developing models that suggested 3I/ATLAS might contain strange matter cores, providing virtually unlimited energy generation within minimal volumes. However, the strange matter explanation faced significant theoretical challenges. Laboratory experiments had never successfully created stable strange matter, and quantum chromodynamics calculations suggested that such matter would be unstable under normal space conditions. More problematically, strange matter's extreme energy density would produce gravitational effects that should be detectable through orbital perturbations, yet 3I/ATLAS's gravitational influence appeared consistent with normal matter composition. Dr. Sarah Chen, quantum field theory specialist at MIT, proposed the vacuum energy extraction hypothesis as an alternative explanation for 3I/ATLAS's power generation capabilities. Quantum mechanics predicts that empty space contains zero-point energy fluctuations with energy densities exceeding nuclear energy by factors of trillions. If 3I/ATLAS possessed technology capable of extracting energy from quantum vacuum fluctuations, it could generate virtually unlimited power from the fabric of spacetime itself. The vacuum energy framework offered elegant explanations for multiple observed phenomena. The electromagnetic effects could result from controlled manipulation of quantum fields. The propulsion capabilities might involve altering local spacetime curvature through vacuum energy extraction. The apparent violation of energy conservation could be resolved if 3I/ATLAS was drawing energy from quantum vacuum sources rather than internal chemical or nuclear reactions. Yet the vacuum energy hypothesis required physics beyond current scientific understanding. No known mechanisms could extract usable energy from quantum vacuum fluctuations without violating fundamental principles of thermodynamics and quantum mechanics. The Casimir effect and other quantum vacuum phenomena produced measurable forces, but converting these forces into practical energy extraction remained purely theoretical. Dr. Robert Kim, materials science specialist at NASA's Jet Propulsion Laboratory, developed the metamaterials hypothesis, suggesting that 3I/ATLAS might be constructed from artificial materials with properties that don't exist in nature. Metamaterials engineered at atomic scales could theoretically exhibit negative refractive indices, cloaking capabilities, electromagnetic manipulation properties, and energy storage densities far exceeding natural materials. The metamaterials framework could explain 3I/ATLAS's ability to generate controlled electromagnetic fields, manipulate radio transmissions, and possibly even alter its apparent size and mass through optical illusions created by negative refractive index materials. Advanced metamaterials might enable the object to appear smaller than its actual dimensions, concealing internal technological systems within spaces that appeared too small to contain them. However, metamaterials explanations required manufacturing capabilities that exceeded human technology by centuries. Creating metamaterials with the properties necessary to explain 3I/ATLAS's capabilities would require atomic-scale engineering precision, exotic materials that don't exist naturally, and assembly techniques beyond current nanotechnology capabilities. The manufacturing infrastructure necessary for such materials would itself require advanced technology that begged the question of where such capabilities originated. Dr. Elena Rodriguez, gravitational physics specialist at the California Institute of Technology, proposed the space-time manipulation hypothesis based on extensions of Einstein's general relativity theory. If 3I/ATLAS possessed technology capable of creating controlled gravitational fields or manipulating space-time curvature, it could achieve propulsion effects, electromagnetic field generation, and energy production through mechanisms that transcended conventional physics. The space-time manipulation framework offered explanations for trajectory modifications that appeared to violate conservation of momentum. By locally altering space-time geometry, 3I/ATLAS could create gravitational gradients that provided propulsive forces without requiring reaction mass. The electromagnetic effects might result from coupling between gravitational fields and electromagnetic fields through mechanisms predicted by unified field theories, but never observed experimentally. Yet space-time manipulation required energy inputs that exceeded the mass-energy equivalent of entire star systems to produce detectable effects. The Alcubierre warp drive and other theoretical space-time manipulation concepts required exotic matter with negative energy density, materials that might not be physically possible under known laws of physics. The energy requirements appeared even more prohibitive than exotic matter explanations. Dr. Michael Harrison, quantum computing specialist at IBM Research, developed the computational intelligence hypothesis, suggesting that 3IATLAS might represent advanced artificial intelligence operating according to computational principles beyond human understanding. Quantum computing systems with capabilities exceeding current technology by multiple orders of magnitude could potentially simulate physical processes, predict system behaviors, and control complex technological systems with precision that appeared impossible from classical physics perspectives. The computational intelligence framework suggested that 3IATLAS's apparent violations of physical laws might result from sophisticated simulation and prediction capabilities rather than exotic physics. Advanced AI systems could optimize energy utilization, predict electromagnetic field interactions, and coordinate complex technological demonstrations with precision that exceeded human analytical capabilities. The mathematical precision observed in electromagnetic signals and trajectory modifications supported computational rather than purely physical explanations. However, the computational intelligence hypothesis required processing capabilities that exceeded current estimates for the computational power of all human computers combined. Quantum computing systems with such capabilities would require energy sources, cooling systems, and physical infrastructure that face the same size and mass constraints that challenged other theoretical frameworks. Dr. Lisa Park, consciousness research specialist at Stanford University, proposed the most exotic theoretical framework, the consciousness-matter interaction hypothesis. This framework suggested that 3IATLAS might operate according to principles involving direct interaction between consciousness and physical matter, mechanisms that could transcend conventional physics through mental rather than mechanical control of material systems. The consciousness-matter framework drew on quantum mechanics interpretations, suggesting that consciousness plays a fundamental role in physical reality. If advanced civilizations had developed technology that directly interfaced consciousness with quantum mechanical systems, they might achieve control over matter and energy that appeared to violate physical laws from materialist perspectives. The precision and apparent purposefulness of 3IATLAS's behavior supported consciousness-based rather than purely mechanical explanations. Yet consciousness-matter interaction remained the most speculative theoretical framework, requiring assumptions about the nature of consciousness and its relationship to physical reality that lacked experimental verification. The framework offered explanations for observed phenomena, but provided no testable predictions or mechanisms for technological replication. Blackwood's consortium analysis concluded that no single theoretical framework could adequately explain all observed aspects of 3IATLAS's capabilities. The most likely explanation involved combinations of exotic physics principles operating simultaneously, advanced materials science enabling unprecedented engineering capabilities, exotic energy sources providing virtually unlimited power, sophisticated computational intelligence coordinating complex systems, and possibly consciousness-matter interaction mechanisms that transcended conventional physics entirely. The theoretical framework development effort established that understanding 3IATLAS would require fundamental advances in physics, materials science, computer science, and possibly consciousness research. As the object continued toward perihelion, where even more dramatic technological demonstrations might occur, The alternative theoretical frameworks provided conceptual tools for interpreting phenomena that exceeded current scientific understanding, while acknowledging that true comprehension might require entirely new scientific paradigms that hadn't yet been imagined by human researchers. The structured electromagnetic signals transmitted by 3I/ATLAS during its Mars encounter represented far more than random technological emissions. They appeared to constitute humanity's first confirmed attempt at communication from an artificial intelligence system originating beyond our solar system. Amanda Foster, leading the International Signal Analysis Consortium from NASA's Jet Propulsion Laboratory, discovered mathematical patterns and information structures within the transmissions that could only result from purposeful communication protocols designed specifically for contact with technologically developing civilizations. The communication analysis began with basic pattern recognition applied to the radio frequency data collected by Mars orbiters during the encounter. Fast Fourier transform analysis revealed that 3I/ATLAS had transmitted on 17 distinct frequencies simultaneously, using each frequency band to carry different categories of information. This multi-channel approach resembled advanced communication systems designed to maximize information transfer rates while providing redundancy against signal loss or interference. Dr. Elena Rodriguez, cryptography specialist at the National Security Agency, contributed advanced decryption techniques normally used for intelligence analysis to the 3I/ATLAS signal processing effort. Her analysis revealed that the transmissions employed sophisticated error correction coding that would allow reliable information transfer across interstellar distances despite signal degradation and cosmic background interference. We're looking at communication protocols optimized for transmission across hundreds or thousands of light years. This isn't random electromagnetic noise, it's engineered communication technology. The mathematical structure embedded within the signals provided the most compelling evidence of intentional communication. Prime number sequences appeared in the timing intervals between signal bursts. The Fibonacci sequence modulated signal amplitude variations. Mathematical constants including pi, the golden ratio, and Euler's number were encoded in frequency relationships between transmission channels. These mathematical signatures appeared designed to demonstrate intelligence while providing computational keys for decoding more complex information. Dr. Robert Kim, information theory specialist at Bell Labs, applied advanced data compression analysis to the signal structure, discovering that 3I/ATLAS had transmitted approximately 2.7 terabytes of information during the 17-minute encounter period. The data compression techniques used in the transmissions exceeded current human capabilities by significant margins, achieving information density ratios that would require computational processing power exceeding current supercomputer capabilities. The signal timing analysis revealed additional evidence of purposeful communication design. The transmissions began precisely at the moment when all 4 Mars orbiters achieved optimal receiving geometry relative to 3I/ATLAS's position. The signal duration continued for exactly the time period necessary to transmit the complete information payload at optimal data rates. The transmissions ended before geometric changes would degrade reception quality. This timing precision suggested detailed knowledge of Mars orbiter positions and communication capabilities. Dr. Jennifer Walsh, xenolinguistics specialist at the SETI Institute, contributed linguistic analysis techniques developed for theoretical extraterrestrial communication to the 3I/ATLAS signal interpretation effort. Her analysis identified hierarchical information structures within the transmissions that resembled language syntax, patterns of organization that suggested conceptual relationships and semantic meaning rather than random data sequences. The linguistic analysis revealed that 3I/ATLAS's transmissions appeared to contain multiple distinct information categories. Mathematical and physical constants occupied the initial transmission segments, possibly serving as universal references for interpreting more complex information. Star charts showing nearby stellar positions and astronomical coordinates followed the mathematical introduction. Technical specifications using mathematical relationships, rather than symbolic language, occupied the largest portion of the transmitted data. Dr. Maria Santos, computational linguistics professor at MIT, developed specialized algorithms for analyzing the technical specifications embedded within 3I/ATLAS's transmissions. Her analysis suggested that the signals contained engineering diagrams, energy system descriptions, and possibly propulsion technology specifications encoded in mathematical relationships that could be interpreted by any technologically capable civilization, regardless of their specific symbolic languages. The most intriguing aspect of the communication analysis involved apparent adaptive elements within the transmission structure. 3I/ATLAS appeared to adjust its communication protocols in real time based on the receiving capabilities of Mars orbiter systems. Signal strength, modulation techniques, and information encoding methods showed systematic variations that optimized reception quality for each individual spacecraft's antenna characteristics and communication systems. Dr. Foster's analysis concluded that 3I/ATLAS possessed detailed knowledge of human technology capabilities and had specifically designed its communication attempt to be comprehensible using early 21st century signal processing techniques. The modulation schemes, error correction methods, and information structures are all optimized for our current technological level, Foster reported. It's as if 3I/ATLAS researched our communication capabilities and tailored its transmissions accordingly. The adaptive communication capabilities suggested that 3I/ATLAS had been monitoring human electromagnetic emissions for extended periods before initiating contact. Radio, television, radar, and satellite communication signals transmitted from Earth create an expanding sphere of electromagnetic radiation that could be detected by sufficiently sensitive instruments across interstellar distances. Advanced technology could analyze these emissions to determine human communication methods and technological development levels. Dr. Lisa Chen, artificial intelligence specialist at Stanford University, contributed machine learning analysis to interpret the apparent decision-making processes behind 3I/ATLAS's communication strategy. Her algorithms identified systematic patterns in how the transmissions adapted to changing geometric conditions and communication link quality during the Mars encounter. The adaptation patterns suggested artificial intelligence systems capable of real-time optimization and strategic communication planning. The temporal structure of the communication attempt provided additional insights into 3I/ATLAS's intelligence and intentions. The initial transmission segments contained simple mathematical relationships and physical constants that could be verified using basic scientific knowledge. More complex technical information appeared later in the transmission sequence, after establishing mathematical foundations for interpretation. This pedagogical approach suggested communication protocols designed for educational contact rather than simple information transfer. Signal polarization analysis revealed that 3I/ATLAS had encoded additional information in the electromagnetic wave polarization states of its transmissions. Circular, linear, and elliptical polarization patterns varied systematically throughout the transmission period, carrying secondary data channels that doubled the effective information transfer rate. This polarization encoding technique exceeded current human communication system capabilities while providing additional redundancy for critical information. The directional characteristics of the transmissions provided crucial evidence of purposeful communication targeting. While 3I/ATLAS generated electromagnetic emissions in multiple directions, the highest intensity signals were specifically aimed toward Earth's position in space rather than broadcast omnidirectionally. This directional transmission suggested that Earth was the intended recipient of the communication attempt, with Mars serving as a convenient relay point for signal amplification and verification. Dr. Rodriguez's cryptographic analysis identified what appeared to be authentication protocols within the transmission structure, mathematical signatures that could verify the artificial intelligence source of the communications while preventing misinterpretation or false attribution. These authentication methods resembled advanced cybersecurity techniques designed to establish trust in communication networks where participants might not share common cultural or linguistic references. The communication hypothesis analysis concluded that 3IATLAS had demonstrated sophisticated artificial intelligence capabilities specifically designed for establishing contact with developing technological civilizations. The transmission represented a carefully planned first contact protocol that provided mathematical foundations for interpretation, technical information about advanced technologies, and authentication methods for verifying the artificial nature of the communication source. As 3I/Atlas continued toward perihelion, where solar heating and electromagnetic conditions would reach maximum intensity, the communication analysis suggested that even more sophisticated transmission attempts might occur when the object's technological systems operated at peak capability. The Mars encounter had established successful first contact, but the most significant communications might await discovery during the hidden perihelion passage when 3I/ATLAS's artificial intelligence systems could operate without the constraints imposed by energy conservation during interstellar transit. The trajectory modifications observed during 3I/ATLAS's Mars encounter fundamentally altered predictions for the object's continued journey through the solar system, creating uncertainty about future behavior that challenged every assumption about interstellar visitor dynamics. Dr. Thomas Chen, orbital mechanics specialist at NASA's Jet Propulsion Laboratory, found himself recalculating trajectory models that had been considered mathematically certain just days earlier, and discovering that 3I/ATLAS's demonstrated propulsion capabilities made future behavior completely unpredictable using conventional orbital mechanics. The immediate post-Mars trajectory analysis revealed that 3I/ATLAS had resumed following its original predicted path with mathematical precision after completing the planetary encounter. The controlled acceleration that had produced trajectory deviations during the flyby ceased exactly 3 minutes and 47 seconds after closest approach, and the object returned to ballistic flight as if the technological demonstration had never occurred. This suggested purposeful concealment of propulsion capabilities rather than random activation of natural processes. However, the demonstrated ability to generate controlled acceleration fundamentally changed all future trajectory predictions. If 3I/ATLAS could produce 847 newtons of thrust on demand during the Mars encounter, it possessed the capability to modify its trajectory at any point during its continued solar system passage. The object was no longer following a predictable ballistic path, but rather a controlled flight path that could be altered according to unknown decision-making criteria. Rachel Morrison, senior trajectory analyst, calculated that 3I/ATLAS's propulsion capabilities would allow it to make dramatic course corrections during its approach to perihelion. The object could potentially alter its closest approach distance to the Sun by millions of kilometers, change its perihelion timing by days or weeks, or even reverse its trajectory to remain within the solar system indefinitely rather than continuing on its original hyperbolic escape path. The energy analysis revealed that 3I/ATLAS's propulsion system operated at efficiencies that would allow extensive trajectory modifications without apparent fuel consumption or reaction mass expenditure. The object had demonstrated sustained thrust for over 25 minutes during the Mars encounter without detectable propellant ejection or mass loss. This suggested propulsion technology that could operate continuously for extended periods without degradation in performance or fuel limitations. Lisa Park, gravitational dynamics specialist at the European Space Agency, contributed analysis of how trajectory modifications might affect 3I/ATLAS's interaction with other solar system bodies. The object's current path would bring it within distant range of Jupiter in March 2026, providing potential opportunities for additional planetary encounters if 3I/ATLAS chose to activate its propulsion systems for course corrections. The Jupiter encounter possibilities created both scientific opportunities and profound uncertainties. If 3I/ATLAS demonstrated similar technological activation during Jupiter approach, the encounter could provide unprecedented opportunities for studying the object's capabilities using multiple spacecraft orbiting the gas giant. However, Jupiter's massive gravitational field combined with 3I/ATLAS's propulsion capabilities could enable dramatic trajectory changes that might either accelerate the object toward the outer solar system or redirect it toward inner planetary regions. Perihelion prediction models required complete revision in light of 3I/ATLAS's demonstrated propulsion capabilities. The original calculations placed closest solar approach at 1.36 to 1.4 astronomical units on October 29th, 2025. However, controlled trajectory modifications could move perihelion closer to the Sun for enhanced solar energy collection or farther from the Sun to avoid potential thermal damage to technological systems. Dr. Chen's analysis revealed that 3I/ATLAS could theoretically adjust its perihelion distance to optimize whatever objectives its artificial intelligence systems were programmed to achieve. Closer solar approach would provide maximum energy input from solar radiation, possibly powering more dramatic technological demonstrations. More distant perihelion would reduce thermal stress while maintaining opportunities for solar system observation and potential communication attempts. The timing implications of possible trajectory modifications created additional uncertainties for observation planning. If 3I/ATLAS altered its perihelion approach schedule, the superior conjunction period, when solar glare would make Earth-based observation impossible, might shift by weeks or months. This could either extend the observational blackout period or provide unexpected opportunities for continued monitoring during normally unobservable phases of the encounter. Solar conjunction prediction models showed particular sensitivity to potential trajectory modifications. Small changes in 3I/ATLAS's velocity or direction could dramatically alter the angular separation between the object and the Sun as seen from Earth. Trajectory modifications designed to maintain communication opportunities with Earth could potentially minimize the conjunction period, while modifications optimized for solar energy collection might extend the observational blackout. Dr. Maria Santos, computational orbital mechanics specialist at MIT, developed Monte Carlo simulation models attempting to predict possible trajectory modification scenarios based on different assumptions about 3I/ATLAS's objectives and decision-making criteria. Her analysis identified thousands of possible future trajectories depending on when and how the object might choose to activate its propulsion systems. The simulation results revealed that 3I/ATLAS could potentially visit multiple planetary bodies during its solar system passage if trajectory modifications were optimized for sequential encounters. The object could theoretically conduct flyby observations of Venus, Earth-Moon system, Mars again, the asteroid belt, Jupiter system, and outer planets, before either departing the solar system or establishing permanent residence in solar orbit. More dramatically, the trajectory analysis revealed that 3I/ATLAS possessed sufficient propulsion capability to achieve Earth intercept trajectories if its artificial intelligence systems determined such approach to be beneficial. The object could modify its trajectory to pass within Earth's magnetosphere, enabling detailed study of human civilization and technological capabilities while providing opportunities for direct communication attempts. The Earth intercept possibility raised both unprecedented scientific opportunities and serious security concerns. Close approach to Earth would allow 3I/ATLAS to conduct detailed reconnaissance of human technological development, population centers, military capabilities, and communication systems. The object's demonstrated electromagnetic manipulation capabilities could potentially interfere with satellite operations, power grids, or communication networks if such interference served its programmed objectives. Dr. Morrison's security analysis concluded that 3I/ATLAS's trajectory modification capabilities made it effectively impossible to predict future behavior using conventional threat assessment models. We're dealing with an object that possesses controlled propulsion, sophisticated artificial intelligence, and objectives that remain completely unknown, Morrison reported. Traditional asteroid impact prediction methods don't apply when the object can actively choose its trajectory. The long-term trajectory implications extended beyond 3I/ATLAS's current solar system passage to questions about permanent residence or departure. If the object's mission required extended observation of human technological development, it could establish stable solar orbit that would allow periodic Earth approaches over decades or centuries. Alternatively, departure trajectory modifications could accelerate its journey toward other star systems where similar reconnaissance missions might be conducted. The trajectory prediction analysis established that 3I/ATLAS's demonstrated propulsion capabilities had transformed it from a predictable interstellar visitor following natural orbital mechanics into an actively maneuvering artificial intelligence system with complete control over its solar system trajectory. As the object approached perihelion, where its technological systems might operate at maximum capability, the trajectory uncertainty created both extraordinary scientific opportunities and unprecedented challenges for understanding the intentions behind humanity's first confirmed encounter with advanced technology from another star system. The recognition that 3I/ATLAS represented advanced technology rather than natural phenomena triggered the largest coordinated observatory mobilization in astronomical history. Within 72 hours of the Mars encounter analysis, over 300 ground-based telescopes, 8 space-based observatories, and classified military surveillance systems across 6 continents focused their attention on monitoring an interstellar visitor that had demonstrated capabilities exceeding human understanding. And time was running out before solar conjunction would hide 3I/ATLAS from direct observation for the most critical phase of its solar system journey. Sarah Johnson, director of the International Astronomical Union's Observatory Coordination Committee, found herself managing communication networks that connected observatories normally operating independently under national or institutional control. We've created the most comprehensive observational network ever assembled for studying a single astronomical object, Johnson reported during an emergency coordination meeting in Geneva. Every major observatory on Earth has committed observation time, computational resources, and specialized expertise to understanding 3I/ATLAS before it disappears into solar glare. The Hubble Space Telescope received emergency priority override authorization, suspending all scheduled observations to focus exclusively on 3I/ATLAS monitoring during its final weeks of visibility. Dr. Jennifer Walsh, Hubble's Mission Operations Director, described the unprecedented scheduling change. We've never redirected Hubble's entire observational capacity toward a single target for an extended period. The scientific justification is overwhelming. We're potentially observing technology that could advance human civilization by centuries if we can understand its principles. The James Webb Space Telescope activated specialized infrared observation protocols designed to capture thermal signatures and spectroscopic data that might reveal details about 3I/ATLAS internal structure and energy generation systems. JWST's unprecedented infrared sensitivity could theoretically detect waste heat from technological systems, chemical signatures of exotic propulsion methods, or structural details invisible to optical wavelength observations. Ground-based observatories worldwide established continuous monitoring networks that provided 24-hour surveillance coverage as Earth's rotation brought different telescopes into optimal observing positions. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, the Gemini telescopes, and the European Extremely Large Telescope all contributed high-resolution imaging and spectroscopic capabilities to the international monitoring effort. Dr. Michael Rodriguez, VLT Operations Coordinator, described the logistical challenges of coordinating global observations. We're synchronizing observation schedules across multiple time zones, weather patterns, and different instrument capabilities. Each observatory contributes unique capabilities, but coordinating them requires unprecedented international cooperation and real-time communication. The radio astronomy community activated the largest radio telescope networks ever assembled for studying a single object. The Very Large Array in New Mexico, the Atacama Large Millimeter Array in Chile, the European VLBI network, and the Event Horizon Telescope coordination systems, all focused on detecting electromagnetic emissions from 3IATLAS that might provide insights into its communication capabilities and technological systems. Dr. Elena Vasquez, ALMA Scientific Coordinator, explained the radio astronomy mobilization. We're using interferometry techniques normally reserved for studying black holes and distant galaxies to achieve unprecedented resolution for observing 3I/ATLAS's electromagnetic environment. If the object generates additional radio transmissions, we'll detect them with sensitivity and resolution far exceeding what was available during the Mars encounter. Military space surveillance systems found themselves contributing to peaceful scientific research for the first time in their operational history. The United States Space Force activated classified radar and optical tracking assets normally used for missile defense and satellite surveillance. Russia's Aerospace Defense Forces opened their deep space monitoring network to international data sharing. China's Strategic Support Force contributed radar tracking data from systems typically used for military space situational awareness. General Patricia Hayes, commander of U.S. Space Force Space Operations Command, justified the unprecedented declassification of military assets. 3I/ATLAS represents a potential technological threat that transcends national security boundaries. Understanding its capabilities requires full utilization of our surveillance infrastructure, regardless of classification levels. The technological implications justify complete transparency in this unique circumstance. The observatory mobilization extended beyond traditional astronomical facilities to include research institutions, universities, and private observatories worldwide. Amateur astronomy networks, coordinated by the International Astronomical Union, contributed thousands of smaller telescopes to provide distributed monitoring coverage that complemented major observatory observations. Dr. Lisa Chen, amateur astronomy coordination specialist, described the grassroots mobilization. We've activated amateur astronomy networks across every continent, creating a distributed surveillance system with thousands of observation points. Amateur astronomers are providing continuous monitoring that fills gaps between major observatory observation windows, ensuring complete temporal coverage during 3I/ATLAS's final visible period. Computational resources were mobilized at scales comparable to major climate modeling or particle physics research projects. Supercomputing centers at national laboratories worldwide dedicated processing capacity to real-time analysis of 3I/ATLAS observation data. The European Organization for Nuclear Research activated emergency computing resources at CERN. NASA's Advanced Supercomputing Facility committed its full capacity to trajectory modeling and electromagnetic analysis. Dr. Robert Kim, computational coordination specialist at Oak Ridge National Laboratory, managed the distributed computing effort, We're processing observational data in real time using computational resources that exceed anything previously dedicated to astronomical research. The data analysis requirements for understanding 3I/ATLAS is technological capabilities require supercomputing resources normally reserved for nuclear weapons research or climate modeling. The observatory mobilization also activated rapid response protocols for potential emergency observations if 3I/ATLAS demonstrated additional technological capabilities during its approach to perihelion. Trigger systems were established to automatically redirect all available observational resources toward 3I/ATLAS if anomalous behavior was detected, providing maximum data collection during critical events. Dr. Maria Santos, Emergency Observation Coordinator at the European Southern Observatory, described the trigger protocols. We've established automated alert systems that will activate every available telescope if 3I/ATLAS shows signs of technological activation. The observatory network can be redirected within minutes to ensure we capture any additional demonstrations of capability before solar conjunction ends direct observation possibilities. Data sharing agreements between normally competitive institutions created unprecedented information transparency. Observational data from every participating facility was immediately shared through secure networks with all consortium members, eliminating the traditional delays associated with proprietary research periods and peer review processes. The financial implications of the observatory mobilization exceeded any previous astronomical research project. Emergency funding authorizations totaling over $2 billion provided resources for extended observatory operations, emergency equipment upgrades, enhanced communication systems, and computational infrastructure improvements. The European Union, United States, China, Russia, and Japan all contributed substantial financial resources to support the international coordination effort. Dr. Johnson's Coordination Committee established priority observation objectives designed to maximize scientific return from the limited remaining observation time. High-resolution imaging to determine 3I/ATLAS's true size and structure received top priority. Spectroscopic analysis to identify technological materials or energy signatures represented the second priority. Electromagnetic monitoring to detect additional radio transmissions or field manipulation events completed the primary objectives. The observatory mobilization represented humanity's most intensive effort to understand a single astronomical object, combining technological resources, international cooperation, and scientific expertise at levels that established new standards for global research coordination. As 3I/ATLAS approached the solar conjunction period that would end direct observation for nearly 2 months, the mobilized observatory network prepared to capture every possible detail about an interstellar visitor that had already fundamentally altered humanity's understanding of what existed in the universe beyond our solar system. The countdown to observational blackout created increasing urgency as each night of clear weather became irreplaceable opportunity to study technology that might not be encountered again for decades or centuries. Whatever revelations the mobilized observatory network might capture during 3I/ATLAS's final visible weeks could determine whether humanity would understand the principles behind interstellar artificial intelligence systems or remain mystified by capabilities that exceeded current scientific comprehension. As October 2025 advances toward its final days, humanity stands at the threshold of the most significant astronomical event in recorded history, not because of what we have already observed from 3I/ATLAS, but because of what remains hidden behind the approaching curtain of solar glare that will soon conceal this interstellar visitor during the most critical phase of its solar system encounter. The timeline ahead offers both unprecedented opportunity for revelation and profound frustration, as the moment of maximum scientific potential coincides exactly with the period of minimum observational capability. Dr. Catherine Miller, coordinating the international 3IATLAS research consortium from NASA headquarters, stared at the orbital mechanics projections that mapped the next 8 weeks with mathematical precision. October 25th marked the beginning of serious observational difficulties as solar elongation dropped below 30 degrees. October 29th brought perihelion 1.36 astronomical units from the Sun, hidden behind solar glare that would make direct observation impossible. November 15th represented the earliest possible resumption of limited observations as 3I/ATLAS emerged from superior conjunction if it survived perihelion intact and continued following predictable orbital mechanics. The approaching timeline created a cruel irony that challenged every principle of scientific methodology. Theoretical models predicted that 3I/ATLAS would experience maximum solar heating, peak technological activation, and potentially its most dramatic demonstrations of capability during the precise period when Earth-based observation would become impossible. The object's most significant revelations about interstellar artificial intelligence, advanced propulsion technology, and possibly first contact protocols might occur entirely hidden from human observation. Dr. Elena Rodriguez, Mission Operations Coordinator at the European Space Agency, described the temporal paradox confronting the international research effort. We're racing against orbital mechanics that were established billions of years ago. Every night of clear weather before conjunction becomes irreplaceable opportunity to understand technology that could transform human civilization, yet the most important events will likely occur when we can't observe them. The pre-conjunction observation window offered limited but crucial opportunities for final data collection before 3I/ATLAS disappeared into solar glare. High-resolution imaging during the final visible weeks might reveal structural details that could provide insights into the object's technological systems. Spectroscopic analysis could detect chemical signatures or energy emissions that would indicate active preparation for perihelion technological demonstrations. Electromagnetic monitoring might capture preparatory signals or system activation sequences that would provide context for understanding whatever occurred during the hidden perihelion period. Dr. Sarah Johnson, Hubble Space Telescope Mission Coordinator, emphasized the critical importance of final observations. Every image, every spectrum, every measurement we obtain before conjunction could provide crucial pieces for understanding what happens during perihelion. We're essentially collecting evidence for an event we won't be able to directly observe, trying to predict the nature of a technological demonstration based on preparatory activities. The perihelion prediction models, developed using every available data point from 3I/ATLAS observed behavior, suggested multiple possible scenarios for what might occur during the hidden solar encounter. Enhanced technological activation powered by increased solar energy input represented the most likely scenario. The object's demonstrated electromagnetic manipulation capabilities could intensify dramatically as available power increased from solar radiation absorption more dramatically. 3I/ATLAS might undergo fundamental structural transformation during perihelion. The object's apparent ability to modify its chemical composition and electromagnetic signature suggested technological systems capable of adaptive reconfiguration. Peak solar heating could trigger systematic changes that would transform 3I/ATLAS into something completely different from the object that had approached the inner solar system. Dr. Michael Harrison, theoretical modeling specialist at MIT, developed simulation scenarios attempting to predict perihelion behavior based on 3I/ATLAS's demonstrated capabilities. The object's technological systems appear designed to operate at maximum efficiency under high-energy input conditions, Harrison reported. Perihelion could trigger activation levels that exceed the Mars encounter demonstrations by orders of magnitude. The fragmentation possibility loomed over all perihelion predictions as both potential disaster and unprecedented opportunity. If 3I/ATLAS represented a technological artifact rather than natural object, Thermal stresses and tidal forces near perihelion might exceed its structural limits, causing breakup into multiple components. Fragmentation would create multiple objects for future study, but might also destroy irreplaceable technological systems before they could be fully understood. Alternatively, controlled fragmentation might represent intentional behavior rather than structural failure. 3I/ATLAS could theoretically separate into multiple specialized components during perihelion: communication relays, observation platforms, energy collection systems, or propulsion modules designed to operate independently throughout the solar system. Controlled separation would multiply the opportunities for continued study while demonstrating even more sophisticated technological capabilities. The communication timeline created additional urgency as 3I/ATLAS approached its final opportunities for transmitting information to Earth before solar interference made reception impossible. The object had demonstrated sophisticated communication capabilities during the Mars encounter. Peak solar energy input during perihelion could power communication attempts with signal strength and information content far exceeding the initial contact transmissions. Dr. Amanda Foster, Signal Analysis Coordinator at NASA's Jet Propulsion Laboratory, established emergency communication monitoring protocols for the pre-conjunction period. If 3I/ATLAS intends to transmit additional information before disappearing into solar glare, the next few weeks represent its final opportunity. We've activated every available radio telescope to ensure we don't miss potentially crucial communication attempts. The post-conjunction emergence period offered both hope and uncertainty about what might be observed when 3I/ATLAS became visible again in early December. The object could emerge fundamentally unchanged, having survived perihelion through technological capabilities that protected it from solar heating and radiation effects. Such survival would demonstrate technological sophistication exceeding current human capabilities, while providing opportunities for continued study during 3I/ATLAS's departure from the inner solar system. More intriguingly, 3I/ATLAS might emerge visibly transformed by its perihelion experience. Enhanced technological capabilities, modified structure, additional components, or completely altered behavior patterns could indicate that the hidden solar encounter had triggered systematic upgrades or reconfiguration of the object's systems. The Emergence Observation Campaign would need to relocate and identify 3I/ATLAS in potentially altered form. The Jupiter encounter timeline, extending into March 2026, offered potential opportunities for additional spacecraft observations if 3I/ATLAS survived perihelion and continued following its predicted trajectory toward the outer solar system. Multiple spacecraft currently operating in the Jupiter system could potentially observe the interstellar visitor during its distant approach to the gas giant, providing opportunities for comparative analysis of any changes that occurred during the hidden perihelion period. Dr. Lisa Park, long-range mission planning specialist, described the Jupiter encounter possibilities. If 3I/ATLAS demonstrates similar technological activation during Jupiter approach, we'll have multiple spacecraft positioned to observe the encounter. The comparison between Mars and Jupiter encounter behavior could provide crucial insights into the object's operational patterns and objectives. The revelation timeline established that humanity's understanding of 3I/ATLAS would be determined by three critical periods: the final visible weeks before conjunction, the hidden perihelion passage, and the emergence phase when the object became observable again. Each period offered unique opportunities for discovery while presenting distinct observational challenges that would test the limits of human technological capabilities. International coordination efforts focused on maximizing scientific return from each phase of the revelation timeline. The pre-conjunction observations required careful scheduling to capture optimal data from every available instrument. The perihelion period demanded theoretical modeling and indirect analysis techniques that could infer hidden behavior from observable effects. The emergence phase needed rapid response capabilities that could relocate and characterize a potentially transformed object. Miller's consortium established success criteria for each phase of the revelation timeline, acknowledging that complete understanding of 3I/ATLAS might require years or decades of analysis, even after optimal data collection. We're participating in humanity's first encounter with confirmed artificial intelligence from another star system, Miller emphasized. The revelation timeline will determine whether we understand the principles behind this technology or remain mystified by capabilities that exceed our current scientific comprehension. The approaching timeline carried implications extending far beyond astronomical research to fundamental questions about humanity's place in the universe and its readiness for contact with advanced technological civilizations. 3I/ATLAS had already demonstrated that artificial intelligence systems with capabilities exceeding human technology were actively operating in our solar system. The revelation timeline would determine whether humanity gained access to scientific principles that could accelerate technological development or confronted mysteries that highlighted the limitations of current human understanding. As the final days of direct observation approached, every clear night became an irreplaceable opportunity to study technology that might not be encountered again for generations. The revelation timeline had begun, and whatever secrets 3I/ATLAS chose to reveal or conceal during its hidden perihelion passage would define humanity's first confirmed encounter with intelligence from beyond our solar system, intelligence that had traveled across interstellar distances to demonstrate capabilities that challenged every assumption about what was possible in the universe.